activity, investigating and making conjectures. Let us now investigate the properties of a parallelogram. For this activity, we will need 4 pieces of sticks of different size. Let us construct a parallelogram using these 4 pieces of sticks. Let us first pick the longest stick to form the base, and then pick the smallest piece of the stick and try to keep it parallel to construct the opposite side. Now we pick the third piece of stick and place it to form the third side of the parallelogram. We place it in such a manner that it touches the edges of the other 2 sides. We now place the last piece, which is the second longest piece, to close the figure. Remember that it has to be placed in such a way that it is parallel to the opposite side. What do we find here? We are not able to create a closed figure of a parallelogram if all the 4 sticks are of different sizes. We will need to cut the pieces of sticks in such a way that the pairs of opposite sides become parallel and equal. We will need to cut the longest piece of stick to match the length of the smallest piece of stick. We also cut the second longest piece of stick to match the length of its opposite side. Therefore, we can conjecture that the opposite sides of a parallelogram are parallel and equal in length. Even if the angles of the parallelogram change, the opposite sides remain equal in length and parallel. What can we say about the diagonals of the parallelogram? Are the diagonals of any parallelogram equal in length? Let us cut 2 pieces of string and use them to estimate the length of both the diagonals. We place a piece of string to join the opposite corners of the figure. We now take another piece of string to join the remaining 2 opposite vertices of the parallelogram. Let us now place both the pieces of string on the table and compare the lengths. We find that both pieces of string are equal in length. So, we can conjecture that the diagonals of all parallelograms are equal in length. Let us test this conjecture using another example of a parallelogram. Let us repeat the steps of cutting out pieces of string to form the 2 diagonals. Now let us place these 2 strings on the table and compare the lengths. Are they also equal? What do we find here? They are not equal. So our conjecture is not correct. We do not need to test this conjecture again on another type of parallelogram. Remember that to disprove a conjecture, we just need one counterexample. Hence, our conjecture that diagonals of a parallelogram are equal in length is not correct. Do the diagonals bisect each other? Let us form the diagonals of this parallelogram using 2 pieces of string. Let us mark the intersection point of the diagonals on the pieces of string using a pen. Now let us cut the pieces of string on the intersection point such that each diagonal is cut into 2 pieces. We find that we have 4 pieces of string. The 2 yellow pieces are equal in length. The 2 white pieces of string are equal in length. Therefore, we can conjecture that the diagonals of a parallelogram bisect each other. We can test this conjecture by repeating this experiment with another parallelogram. We now change the angles of the parallelogram. Will this conjecture still hold true? We cut the diagonals at the intersection point and still find that the cut pieces of string of one diagonal are equal in length. Thus, we can conjecture that the diagonals of a parallelogram bisect each other.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you, and let the math finally start mathing.